Welcome. Giving continuity to decide the equation of the tangent plane in the normal line to a given surface. In this video, we're going to see how do we find the equation of that tangent plane and how do we find the equation of that normal line to that given surface. We have to bear in mind that the concept of this equation of the tangent plane in the normal line, we are talking about two surfaces. One is a plane and another one is another surface which is curved in shape, and both of them, they are contacting in a point. So it's crucial for us to have the coordinates of that point in order for us to proceed with solving the equations or to find the equation of the tangent plane and the normal line. So as you can see from the equation of the tangent plane, we are forcefully and required to find the partial derivative of the equation of the surface with respect to x, with respect to y, and with respect to z. And likewise, for the equation of the normal line, we have to find respect to x, y, and z. This f is this function that is given to us here. If you plot the graph of this function, it's going to give us a curved surface, and from that curved surface, we want to locate this plane in this point 1, 2, and 4. So the first thing that we should do is that we have to find the partial derivatives of this function here with respect to x, y, and z. Partial derivative with respect to x is equal to, in all this case, you're going just to use the power rule. And if you don't know what is the power rule, you can go for the playlist we have about the derivatives, and you're going to see the rules of differentiation, which will explain all the rules that you come across when you're solving problems involving derivatives. So we are going to have these two going to come down. So we're going to have 2x. For y, we are going to have 2y, and for z, we are going to have 1. The derivative of z here is 1. So we have to find what is the value of these partial derivatives at the given point. Whenever you have a point like this, you should know that the first coordinate is the coordinate of x, the second is of y, and the third is the coordinate of z. So we have x1, y1, z1. So partial derivative with respect to x at that point P is equal to 2 into that coordinate of x, which is 1, so we're going to have 2. Likewise, we're going to do for y. So we're going to have 2 into the coordinate of y is 2, so we're going to have 4, and the partial derivative z, here, it's going to be 1, which is the partial derivative of z, into nothing, because there is nothing here, there's no variable, so it's going to give us 1. So we have found the value of the partial derivative at the given point. So now we have assured that whatever the equation we're going to get from these values of the partial derivatives is going to give us a surface and a plane that are touching at that point. So the next thing we have to do is we try to represent this equation by just replacing the values. This is going to give us the equation of the tangent plane. So partial derivative with respect to x, we have seen here that the value is 2 into x minus x1 is 1 from it, plus with respect to y, which is here, is 4, y minus it's 2, the value of y1, plus 1, which is the partial derivative with respect to z, into z minus 4. All of this is equal to 0. So we have replaced the equation tangent plane. Now what we have to do is we have here 2x minus, if we write this, we have 2 plus 4y minus 8 is equal to 0. So 2x plus 4y plus z, all of this is going to give us, we have minus 2 plus 8 plus 4. We're just putting all of these that have a common minus term, minus sign, we're going to put it in evidence, and then we're going to join them all inside. So this is going to give us 0, and the value of 2 plus 8 is 10 plus 4, 14. So we're going to have 2x plus 4y plus z minus 14 is equal to 0. This is the equation of the tangent plane. Now the next thing we're required to find is the equation of the normal line. So as from the formula here, what you have is, this is tangent plane. So what we have here is x minus the coordinate of x1 is 1. All of this should be divided by the partial derivative with respect to x that we have found here too. Then we are going to have y, the coordinate is 2, the partial derivative is 4, and finally we are going to have z, which is 4, and this value is 1. This is the equation of the normal line, and it's done.